Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to find indefinite integrals, so you can take this as the continuation of Calc 1 topics. But this time we are having either difference of squares or sum of the squares popping in some part of the integrand. So I handpicked 3 exercises today because in the first one you have polynomials involved. In the second one, you have the logarithmic function involved. And in the last one, right here, you have sine and cosine trig functions involved in those integrals. And for each of them, we're going to use a set of formulas. And let me show you what they are. And these formulas are the integrals involving inverse trig functions. As you see in the first one, you have the difference of the squares in square root sine. So you have a number a and a variable u. So when you see like a squared minus u squared and together with the radical sign, so that means this is arcsine type integral. Okay, so in the second one, you have the sum of the squares in the bottom. So that's an arctan type integral. And in the last one, you have the difference of squares, but this time the position of a and u somehow like changed. So the first variable is squared. The first thing is squared is the variable u, and the second one is the number a squared. So this is arcsecant type integral. And also, I want to point out that please refer back to the basic integration rules right here because this was something that we sort of like developed in Calculus 1. And 18, 19, and 20 is just something that I added. Those were the formulas in the previous slide, as you see. So to be able to attack the exercises today, we're going to immensely use the u substitution and the basic integration rules, but mostly 18, 19, 20 for these exercises. And please have like a good revision of u substitution beforehand because we're going to start using them right away. All right, let's get started. All right, let's look at part A. It's 1 over x radical x to the fourth minus 4. One quick observation here is that x to the fourth is the square of x squared, and 4 is the square of 2. So inside the radical, it looks like it's the difference of squares, and then the first term is the variable, the second term is the number squared. So it looks like one of those known integrals involving inverse trigs. In fact, it looks like the third one, right? Variable squared in the radical sign minus a number squared, and then you have u outside the radical, right? So why don't we start with calling? Well, first of all, this is let me just write what I just said: x squared minus 2 squared. So I'm going to call u to be x squared because this term looks like this term here looks like u squared, right? And then this term looks like a squared, right? So so for that reason, let's start so like doing that. Well, then du, so this is a, du is going to be 2x dx, but we got to be careful because I have dx over x over there to replace by the u version of that. This is what we do in the u substitution, right? Once we have the conversion, then we got to convert everything into u, right? So what I'm going to do here is that I'm going to divide everything here by 2x squared and 2x squared, so that on the right, after the cancellation, I have dx over x, which is exactly what I have here. Okay, and then on the left, what do you have? Du over 2x squared, but x squared is u, so it's in fact du over 2u. Okay, so I'm going to go ahead and replace dx over x by 2 du over 2u, and the radical term would be just u squared minus a squared. Okay, in other words, 1/2 out. So this integral turns out to be du over u squared minus a squared. Going back to the formulation here, This is 1 over a, the integral of that is 1 over a arc secant absolute value of u over a. Okay, so let's go back. I have already 1/2 out. And a equals 2, obviously, right? So this is our a. Let me just write it carefully. A equals 2. Okay. So then 1 over 2, another 1 over 2, arc secant absolute value of u over a, which is also 2, plus c. But let's just combine everything to wrap up. So 1/4 arc secant u, but u is originally x squared, and we don't need to have the absolute value sign here. So this is going to be x squared over 2 plus c. Okay. So again, this is a good u substitution problem. Together with the use of one of the integrals involving inverse trig functions, and in this particular case, we used arc secant type integration. All right, that's the end of part A. Please move on to my next video to see what I'm going to do for the second part. All right, bye.